All right, we'll start with the easiest one, the zero exponent property. The zero exponent property is the defined rule for when zero is the exponent. You probably already know it. Anything to the zero power is equal to what? 1, always. Every time, never going to change. Okay? Examples. 5 to the 0, 1. Example B. -5 to the 0. Parentheses involved, doesn't really matter. Anything to the 0 power is 1. It can be something really, really complicated. If it's to the 0 power, what's the answer? 1. Okay, that's pretty complicated because it's something added and subtracted inside as a base. But it's got the 0 exponent, so it's 1. It could be a basketball. To the 0 power is equal to 1. Always. No matter what it is. If it's to the 0 power, it's a 1. Okay? Changes to a 1. Easiest rule we've got for exponents. Definitely. Definitely the easiest rule. Okay? So keep that in mind, because if anything, when we do subtraction, if it ends up to the 0 power, if we do addition of, the bases are the same, we multiply, we would add exponents, it ends up being 0, it turns into a 1, that sort of thing. As we go to simplify more and more complex expressions, that could happen. So the next thing, the little bit more difficult, is the negative exponent property. Okay, negative exponents exist, but we try to, when we simplify problems, make them no more. Okay, we don't want an answer to have a negative exponent in it. Okay, negative exponents are really easy to fix, but you got to do everything else first. Okay, so if I say nothing else, one thing you need to remember about the negative exponent property is do all other exponent rules first, and then we're going to fix the negative exponents. Okay, and the way we fix negative exponents is we take this rule. We got a base with a negative exponent. I've got a to the negative n power. It doesn't matter what that base is, doesn't matter what that number is up there, it's just a negative number as an exponent. The rule is that you can change that to a positive exponent by moving its location. Right now, it's just regular base a to the negative n. It's like it's in the numerator. To make it a positive exponent, you move it to the denominator. So this becomes 1 over a to the n. We'll see several examples, real simple ones, and then we'll build up to the harder ones later on here. If we start out with a problem with a negative exponent in the bottom, to make it positive, it's going to move locations. So from a bottom, it's going to move to the top to make it positive. Okay, those are the exponent rules for negative exponents. We don't do the negative moving. We don't move anything until we're finished doing all the other rules. We'll do all the other rules first and then move the negative exponents. Okay, keep that in mind, because we'll get to some that have several negative exponents in it, and if you move them at the beginning, you'll end up having to move them again at the end. So why not just wait till the end to move them? That's the easiest thing to do. Wait till the end to move them. So that's why I'm saying do all the other exponent rules first. So let's look at some examples of that. Let's write simplify using only positive exponents. Okay, so remember, we never want to leave an answer with a negative exponent. Okay. So 3 to the negative 2 power. There's no other exponent rules to do. Like as far as, there's not another base of a 3 that we would add exponents with that we're multiplying by or anything. There's no division going on at the moment. So we want to go ahead and just move this to make that a positive exponent. All right. So if there's nothing in the denominator there, we can assume that this is the numerator. To make it a positive exponent, it's going to go to the bottom, which will be 1 over 3 squared, which is 1 over 9. I would actually take either of those answers. There are going to be times when you want to work out that number. If this was a really big number, like 25 to the 6th power or something like that, it's pretty big, you'd probably leave it in exponent form. We're going to work that number out there for that one.
So you got the 1 over 3.
3 squared. So I moved this. It was in the numerator. I moved it to the denominator, and it changed the sign. The 1 is what it's kind of like. If there's nothing else left in the numerator, there's a 1 always there. It's kind of like if there's nothing in the denominator, what's really there? A 1. It's that idea. Okay. So negative exponent moves to the bottom, makes a positive, and then we can work it out from there if need be. Won't always be that way. Maybe it's a letter to a negative exponent, something like this: x to the negative 3, and then y to the positive 4. Here's one with letters. Okay. Can we combine those? Why not? Different bases. This is an x base, that's a y base, so they can't be put together, but we can rearrange it so that it has positive exponents only. Which one needs to move? The x, because the y is already a positive, so it doesn't need to move. Where does the y to the 4th stay? At the top. The x to the 3rd moves to the bottom and becomes positive. And that's all there is to that one. There wasn't anything else we could do for that. Here's another one. Let's say we had 1 over 2 to the negative 3. So 2 is our base there with the negative 3 exponent. Right now it's in the denominator. How do we change it to a positive exponent? Put it in the numerator. 2 to the 3rd. Technically that's times 1, but there's not, 1 times 2 to the 3rd is not going to change it. And that works out to be 8, right? So I would actually, depending on the situation, there's the exponential form written with answers with exponents. There's the worked out number form. For the most part in this section, we'll work out most of the numbers. And on the homework, I'll tell you which ones to work out, which ones not to. All right, so let's look at this one. X to the 5th over y to the negative 7. Which one's okay? Doesn't need to move. X to the 5th, it's positive, so it doesn't move. So we just need to move the guy that has a negative exponent. Where does the y to the negative 7, where does it go? To the top and becomes what's left in the numerator? In the denominator. The numerator, x to the 5th doesn't move. Y to the 7th comes up there. What's in the bottom? Technically a 1. There's nothing, you don't have to write it, but technically there's a 1 down there left over. That's not very difficult. So far, it's pretty easy. Let's say we had w to the negative 2 over t to the negative 4. A little bit more complicated here. What needs to move? Both of them. So the W is going to go where? To the bottom, and the T would go to the top. So we end up with W squared on the bottom, T to the 4th on top. Not too bad. Still pretty easy. One over 5 in parentheses to the -2. So we're starting to incorporate some of our other rules with this example. It starts incorporating the other rules a little bit. What's the rule for parentheses with an exponent outside? Distribute, that's right. So the 1 ends up with what? A -2, and the 5 ends up with a. So it's 1 to the -2, 5 to the -2. And how do we fix those? Swap them and then work it out, right? So it's actually 5 squared over 1 squared, which 5 squared is 25 over 1. So it's just 25, the final answer. But we applied the first rule, then we fixed the negative exponents. Okay? Take a little practice, but we're going to get there. Example K. Let's do this one. Parentheses, x to the -3 squared, y to the -8. So we're getting a little bit more complicated with things. But again, all of the rules first, and then negative exponents last. What's the first rule we should follow here? Distributed property with the 2. Does the y get the 2? Why not? Well, not necessarily that it's a fraction, but it's not inside of what? It's not inside the parentheses. So the x is the only thing that gets that 2. So that's going to turn into x to the -6 and y to the -8. And that's a lot like example I. What happens to it? Flip, yeah, you basically just flip it. Y to the 8th, x to the +6, and that's it. Okay. X to the -7 times x to the 5th over y to the 8th times y to the -3. Okay, so again, we got to remember our rule to do everything else first. Okay, so what happens on the numerator, the top? They're multiplying on the top, so what's the rule? Add, and that's how we're getting the -2. X to the -2 on top. On the bottom, they're multiplying, so what do we do with the exponents? Add them, so 8 plus -3 is 5. So here, this problem is a good example of why you want to follow the other rules first. Because if I had moved these, I end up having to do subtraction of exponents instead of adding. And then I'm going to end up having to fix them again at the end. Okay. So here I got x to the -2 and y to the 5th. What needs to move? Where's it go? To the bottom. What about the y to the 5th? Stays where it's at. So that's x squared, y to the 5th. What's in the numerator? 1. If nothing else is there, there's a 1. And there's our final answer for that one. Three x to the 5th, y squared, in all that in parentheses, to the negative 2 over 12 x to the third y to the second. Kind of stepping up our game a little bit, going a little bit more difficult problem. What's the first thing that should be done? Distribute the top with the negative 2. So we ended up with 3 to the negative 2, x to the negative 10, y to the negative 4. Does anything change on the bottom? No, not yet. Now we're going to follow all our other rules first before we deal with those negative exponents. We're going to have to deal with them, but not right now. What's the rule that we need to deal with here? What was it? Subtraction. That's right. So what gets subtracted? The exponents on the x's and y's. So we've got negative 10 minus 3. Negative 13. Where does that go? Top. Always to the top. Remember when we did the division rule? I told you the answer always goes to the top. Always. So it's going to be 3 to the negative 2, x to the negative 13. And then we have negative 4 minus 2, which would be y to the negative 6. What's still in the denominator? 12. The x and the y have been taken care of over here. Okay? We did the subtraction rule. Answer always goes to the top with the subtraction rule. Always. Okay? Now, let's fix some stuff. What gets moved? 3 to the negative 2. What about x to the negative 13? And then y to the negative 6. All of the entire numerator gets moved to the denominator. So that's going to be 12 times 3 squared times x to the 13th times y to the 6th. What's in the numerator? A 1. Nothing else left. So it's just a 1. Now let's work out the bottom a little bit. We can do those numbers there. They're not too big. 3 squared is 9 times 12. 108. Let's see here. Example n. Parentheses 2x squared y to the negative 5 in parentheses all to the negative 4. That's it. What rule happens first? Distribute the negative 4. So what do we have then? All right, yeah, be careful there. Negative 4 times negative 5 turns into be a positive 20. Be careful of that. That's the hook on this problem. Okay. Now what moves? Okay. So what's left in the numerator? Y to the 20th. On the bottom, we got 2 to the 4th, x to the 8th. What is 2 to the 4th?